Hello, good evening, vanakkam, bonjour, hola, sat sri akal, namaskar, good evening, all my lovely warriors. Welcome to the most expected series for your Term 2 Physics Board examination with me, Shreyas, your physics master teacher. And nice to see all of you live out here. Hello, Srinivatsan, Kalyan, Anirudh. Nice to see you back. Vitrivel, Pavitran, John. Hello, hello, hello. Okay, let's just see what your messages are. Good evening. So today's session is all about, giving you the most expected pattern, what kind of questions you should expect. You will understand the difficulty level, also concepts. Remember, today is mainly questions. But apart from that, you can also get derivations in today's session. In the actual exam. So derivations, I have not put it up because I have done a session just on derivations yesterday. Please check out the video which is there in the same channel. Vanakkam, all excited? All ready to rock tomorrow? Atoms and nuclei does not have so much of weightage, but it is easy chapter. Thank you, Komal, so much. Thank you so much. My confidence level going downhill. T square Nikhil O. After today's session, I'm pretty sure it will go uphill. Hi Dharnesh, स्वागत आहे तुमचं पण. चला चालू करू. Let's start. So do not forget to smash the like button and hit the subscribe button in case you are not yet subscribed or like the channel. And today's session is the most expected series with me, Shreyas, your physics master teacher. Anything you want to know or you want to ask, you can ping me on my Instagram handle. And yes, thank you for that like and that subscribe. And remember, the PDF is going to be available on the Telegram channel. Link is there in the description box. Make sure you check it out. Indrani Paul, watch my semiconductor video. I have posted it. Just search on YouTube. Shreyas Sir Semiconductor. There is a one-shot video. Watch that one-shot video. It will be all clear. All right. All right, Jishnu. Thank you so much. Let's begin with the first section. Section A. Simple questions, easy questions, 2 markers. It's going to be very, very easy, but you should know what to write. You should know how much to write. You should also know what and all points are important, what and all is not important. So let's focus on all those concepts from the board perspective. Question number 1 coming up on your screens right now. In a pure semiconductor crystal of silicon, if antimony is added, then what type of extrinsic semiconductor is obtained? Draw the energy buoyant diagram which is formed. Yes, clumsy man, I'll be giving you some tips just before the session ends towards the end. All right. Hi, Jalban, welcome. Jaya, it should be around 1.5 to 2 hours. Okay. So many students get confused as to which one is pentavalent, which one is trivalent, what kind of impurity it is. So I generally suggest my students to remember this word pa, and Bagi. Bagi was a movie. It's a Bollywood movie. So there is a movie called as Bagi and Pa. Now this is phosphorus. Phosphorus, yes, P stands for phosphorus, guys. Yep. So this is phosphorus, antimony, and this is arsenic. So this is your N type. So this is basically your pentavalent impurity, and this is your trivalent impurity. This is your trivalent impurity. This is barium, this is boron, aluminium, gallium, indium. Yeah. So now if you notice in this particular question, antimony is given. Antimony comes over here. It's a pentavalent impurity. If it is a pentavalent impurity, then obviously it will have one donor electron. So because of that, you will see it will become an N type of semiconductor. It will become N type of semiconductor. And if you look at the band structure, there will be the conduction band. You will have the valence band. So because of that extra electron, the conductivity increases because of a donor energy level. Yes, very good. Okay, I hope this is clear. Murli, this will be for around 2 hours, 1.5 to 2. So you can see I have put up the printed solutions as well, printed answers, and all the important points that you should note about it. So pentavalent impurity, that's antimony. Let's move on to the next question. Consider 2 different hydrogen atoms. The electron in each atom is excited. Now it is possible for the electrons to have different energies, but same orbital momentum, angular orbital momentum according to Bohr model. Is that possible? If so, justify your answer. So baggy is basically your boron Jishnu Rasai. Baggy is nothing but boron. Okay, that's your boron. Okay, then it will be A stands for aluminium, then gallium and indium. Okay, that's your baggy. This was phosphorus, antimony and arsenic. That was Pa. Okay, moving on to the next question. Let's think about it. First of all, these two electrons or these two atoms have different energies but same orbital angular momentum. According to Bohr's theory, angular momentum is nh by 2 pi. If L is same, naturally the value of n should be also same. What is n? Your orbit. So hence the orbit also should be the same. If orbit is same, obviously the energy also should be the same. How is it possible that angular momentum is same, hence energy is same, but the question says they have different energies? Not possible. Hence I will say that no, if two orbits have different energies, they should have different angular momentum. So it is not possible, and I'm using Bohr's postulates, angular momentum quantization, and also the another postulate saying that for a fixed orbit the energy is fixed, it is defined. Each electron stays in stable orbits which has defined energy levels. Keep this in mind. No, EG level is not required, Bhargav. You can just leave it as it is. Okay, just leave the energy level diagram. Don't have to put the value of EG. Is that okay, my warriors? Okay. Oh, no problem, Irix. You can join in right now. Term 2 paper will not be very hard. It will not be very easy, but it will be moderate, I feel. Derivations will be the toughest part because many students would not have studied the derivations. That's where the toughness will come. And some questions where people will forget the theory of semiconductors or atomic structure, God knows. Next question. Explain how does photoelectric current and kinetic energy of the photoelectrons emitted in a photocell vary if the frequency is increased but keeping the intensity same? Okay, what is changed, what is same? Let's first understand that. If the frequency is increased, if frequency of the photon is increased, the energy of such a photon will also increase. Energy of that photon will also increase. Now, according to the photoelectric equation, energy of the photon is phi plus kinetic energy. So if energy increases, phi does not change, kinetic energy must increase. So the second answer I immediately got it. Kinetic energy must increase according to the photoelectric equation. You should mention the photoelectric equation and then explain it. Next thing that you should know over here, intensity is same. If you notice, intensity is same. So if intensity is same, that means number of photons which are incident, they are same. If the number of photons are same, what does it mean? Number of electrons ejected, they will also be same. If they are same, then what will happen, guys? Electrons are also same. Obviously, current will also be the same value. That's all. That's the answer. Last part is show the graphical variation of the above two cases. So for that, you can just draw a simple graph. Current is same for different intensity. So you can put intensity over here, and what is this? Keeping the intensity same. What is the effect of photoelectric current when the frequency is increased, keeping the intensity same? Okay, now remember one thing, since intensity is the only factor which affects, affects the current, and frequency has no role to play. So with intensity, I know the current increases, but if you look at frequency graph with respect to current, it will be constant. Frequency graph will be constant. And also keep this in mind, the graph won't start from 0. The graph will start from some value called as F0, which is your threshold frequency. Remember that. All right. I hope this is clear. Why this graph started from F0? Because only after the threshold cutoff frequency will the photoelectric effect start. For this graph, you can probably draw the graph of let's say stopping potential versus frequency, and we all know it is one straight line like this. As frequency increases, stopping voltage increases. Stopping voltage is directly related to kinetic energy. More stopping voltage, more kinetic energy. Do you remember that? Chan, that will be too late. Yep. Will the questions from circuit diagram finding current will come? Can come, because you have studied Ohm's law in the previous chapters, so why not? It can come, definitely. Is that okay? Can we go ahead? All right, let's move on. Can we? Are we going to discuss online CBSE sample question paper? No, sample question paper I have already discussed long time back. It's there on the channel. Just search for sample paper Shreyas Sir physics. You will get it. Yep. Let's go ahead. Yes, numericals will also come, Priyadarshini. Hold on. Name the device which converts the change in intensity of illumination to change in electric current flowing through it. Plot IV characteristics for this different intensities. Also name the some applications of this device. What is that device which converts change in the intensity to change in electric current? Electric current is generated from light, that is a photodiode. Obviously it is nothing but a photodiode, and we all know a photodiode, light falls on it, it is used in reverse bias. The next part is, what is the application? It can be used for digital signals, it is used for modulation demodulation circuits, it is used like optical sensors, it is used to detect obstructions in the path, or it can be also used for burglar alarm. Yes, so many things. And the last thing, plot the IV characteristics. Since it is in reverse bias, remember that your IV characteristic graph will come in the third quadrant. This will be your leakage current, which is very, very small. And if you change the intensity, the current also increases. That small leakage current also increases. Hence, you will notice the graph is different if the light is more intense. So these lines you have to draw, I1, I2, I3. You can draw 2, 3 intensities, that is fine. Yeah. Solar cell? No. Be careful, solar cell is not the answer, because this is a device which converts the change in the intensity. You want to detect how much is the change in the intensity to electric current. I want to detect the changes in the light. I don't want to create electricity. I just want to detect the change. Understand? It's a device which converts the change in the intensity to change in the electric current flowing through it. Is that okay? I put up all the answers also over here. Yep. Okay. Yes. So some of the questions are, but some of the questions are different. Don't worry. Only few questions I have put it most expected, because I want you to revise them. Now, next question. Given the ground state energy is minus 13.6 electron volt and Bohr's radius is this much, find out how the de Broglie wavelength associated with the electron orbiting the ground state would change when it jumps into the first excited state. Yes, Riji, I do remember you. Okay, let's try to figure this out. First of all, given the ground state, I don't think I might need these values, but I never know. Find out how the de Broglie wavelength with the electron will change. What is the de Broglie wavelength of an electron which is orbiting an atom? De Broglie wavelength in general is h by p. Because that electron is going in an orbit, it obviously has momentum. Not just momentum, but because it is rotating in an orbit, it also has angular momentum. Do not forget that. And we all know from the 11th standard topic, angular momentum is r cross p. So p is therefore L divided by r. So p is L divided by r. So how about substituting it over here and see what do we get? We get h divided by L by r. So it will be h r divided by L. Now why did I do this? I wanted r in the answer because I know that the state is changing. It's going from the ground state. Notice the question. It is going from the ground state where n is equal to 1 to the first excited state. First excited state means n is equal to 2. So when it jumps, what will happen? The radius will change. radius will change, L will change, so many things will change. No, we cannot use hc by lambda, Saundarya Abhirami, because hc by lambda is the energy of a photon. Electron is a different, electron is a particle, light is different, photons energy is different. Okay, so now what we need to really look at is how will radius depend on n. What is the proportionality relation? What is the no, we can't use Rydberg. Anirudh, this, see guys, de Broglie wavelength is the wave with the electron. It is not the wavelength of the photon emitted. Guys, get to know the answer, get to know the concept of the question. De Broglie wavelength is the wavelength of the electron. I am not asking you how much is the wavelength emitted when it jumps. So you will not use Rydberg's constant. Understood? Radius is proportional to n square. Good, you guys asked this question. I'm so proud of you. Yes, Sabri, you can use that as well, but I think that part is deleted from the syllabus, at least for the CBSE part. Now, over here, what is L? L is directly proportional to n, right? Do you remember L is nh by 2 pi? L is nh by 2 pi. That's it. Hence, what will I get? Lambda is proportional to n square by n. One of the n goes. So basically, lambda is directly proportional to n. Now I know if n goes from 1 to 2, obviously this lambda will also become twice. Lambda will become twice because it's going from ground to first excited state. So wavelength will also double. That's it. Done, done. Answer is done. Okay, moving on to the next one. Understood, guys, how to solve the question? Let's move on to the next one. The image of a candle is formed by a convex lens on a screen. The lower half of the lens is painted black to make it completely opaque. Draw the ray diagram to show the image formation. How will the image be different from the one which you obtain when the lens is not completely painted black? Let's try to do this. So first of all, let's imagine a lens. Let's imagine an optical axis. Let's also draw your candle. This is your object. This is your candle. And the rays of light will go like this, meet here. Maybe some of the rays will go and meet here. Actually, there will be more rays like this, which will go and meet here. But 2 rays are enough to locate an image. So this is where your final image will be located. Now it is clearly mentioned in the question, the lower part or half part of it is basically completely covered. So basically it's opaque. Nothing can pass through it. If it was not opaque, then what would happen? There will be more rays of light which would have traveled through that part. But now they can't because it is blocked by the paper or it is covered. So what will happen? Will the image be half? No. Image will still be there. It will be completely formed. Just that very few rays will meet or half the rays will go away, so the intensity will become less. That's all. The intensity will become less. That's the answer. The image will still be formed, but only few of the rays will go and rest of the rays will not reach there. That's all. Definitely, Jishnu Sai, I hope. Me too. Atoms and nuclei are not very important, but they are easy questions. There are easy derivations also in it, and not more than maybe 5-10 marks from that entire chapter. Yeah, around 10-12, that's it. Let's move on to the next one. Okay, should we draw? What should you draw? Yes, you should draw. If you don't draw, then you will lose marks. Please draw. You have to draw. Draw the ray diagram. Come on, it is given in the question. If you don't do what I have told, then you will obviously lose marks. Next, define the magnifying power of a compound microscope when the final image is formed at infinity. Why must both the objective and the eyepiece have short focal length? Explain. Simple. So magnifying power of a microscope, I had told you that a microscope is basically a lens combined with a magnifying glass, and that lens which is near the object is your objective lens. So it's the magnification of the objective lens into the magnifying power of the magnifying glass, which is nothing but your eyepiece, I had shown you the ray diagram yesterday, eyepiece behaves like the magnifying glass, and the objective lens just creates a real image inverted close to the eyepiece. That's what it does. It just brings the image over there. What is the magnification of the objective lens? It comes out to be L by focal length of the objective, and magnifying power for a magnifying glass is 1 plus d by f if it is least distance, and it is just d by f if the image is formed at infinity. Since the image is formed at infinity, just put d by f, but the focal length is of the eyepiece. So that's your magnifying power of the microscope. Last things over here, why are the focal lengths short? You can clearly see they are in the denominator. So the magnifying power is inversely proportional to FO, inversely proportional to obviously FE also. So FE if it is less, or FO if it is less, magnifying power will increase. Hence that's the answer. Pratik, I doubt if it can be good, but you will score something better. I can't assure you good, but I will assure you it will be better than what you would get if you do not attend the session. Won't negative sign come? Well, if you want to put negative sign, you can put it, but I'm more interested in the magnitude. If you want to put minus, you can put. That minus sign just indicates that it is inverted. It is just inverted, that's all. Okay, all right. Can we use V0 by U0 instead of L by F0? No, Syed, because if you see the derivation, or even if you see the NCERT book, they have mentioned that V0 roughly is equal to L and U0 is roughly equal to F0, and that is the approximation that you do so that you know the image is formed at infinity and all of that. Nuclear reactor working, not so much, but just read through it for sure. Telescope magnifying power is F0 by Fe. Remember telescope, what is the magnifying power? F0 by Fe. Okay, let's move on to the next one. All right. Some people are more interested in when the session will end. Guys, those of you are thinking when the session will end, now you guys are not interested in the session, so you can please leave. It's okay, fine. What is meant by the term doping of an intrinsic semiconductor? How does it affect the conductivity of a semiconductor? You can leave, Jishnu. What is the meaning of the term doping of an intrinsic semiconductor? Doping is basically adding impurity to what? Intrinsic. Intrinsic means pure semiconductor like silicon or germanium. How does it affect the conductivity? When you add impurity, it can be of two types. One is N, one is P. N adds electrons, P adds holes. So these are basically your holes. And when you add electrons and holes, essentially it increases the conductivity. Remember, the conductivity of a semiconductor depends on both hole as well as electrons. Electrons also flow, holes also flow. That's how the total current flows. That creates the current. In a conductor, it's only the electrons which move, which creates the current. So when you either increase the electrons or the holes, the conductivity is dependent on both of them. So the conductivity basically will increase. That's the answer. These are the steps. Now, remember, whenever you write an answer in the exam, especially CBSE board or any board, remember, always articulate, always think what you're going to write, else you might just start writing and then realize that should not be my opening statement. I should have started with this. So always think, articulate, make a rough picture for 30 seconds and then start writing. It will be much better. I put up the answers out here as well. So N type will be pentavalent, trivalent is going to be P type. Next, in a half wave rectifier, yes, I'll be uploading the PDF in the Telegram. How many questions? A lot of questions will be very similar looking from today's and yesterday's session. Let me tell you that yesterday's session, do not ignore derivations, very important. Many derivations will come, at least those questions related to the derivations. In today's session, I'm not doing any derivations because it's already done, but derivations is sure shot. It's guaranteed marks scoring. In a half wave rectifier, the load resistance is this much. The diode has a forward bias. Actually, there is only one diode, has a forward bias and a resistance of 100 ohms. Voltage in the winding is this much. find the current, voltage, frequency, etc. So let's first of all draw and visualize the half wave rectifier. So first of all, you have the you have the transformer. This is your winding. That winding gives you the voltage 110 sine 314t. This is the voltage that you are getting. Now, from this voltage, what you are doing, you are basically converting it into a half wave rectifier. Rectifier means converts AC into DC. So just draw this and just show a load resistance. That's it. The resistor's value is 1 kilo ohm. That means this will be 1000 ohm. You are measuring some voltage across it. Let's come to that later on. The diode also has a resistance of 100 ohm. So do not forget to write 100 ohms over here. This is your half wave rectifier. That's all. Half wave rectifier has only one diode. Makes sense? Everyone? Okay. Now, the next thing is figuring out what is the current which will flow. The current which will flow, it will be like this. Current will only flow in the clockwise direction because that will make the diode in the forward bias. So how much will be the current? The current will be what is the voltage upon the total resistance, that is your Ohm's law. The voltage is just 100. This is your max voltage. This is your max voltage. So it will be 110 by total resistance, which is 1000 plus 100, which is 110 divided by 1100. So 00 cancels. This will be 1 by 10 or basically 0.1 ampere. So this is your value of current, which is one of the questions. That's it. The frequency of the DC ripple, this is something which we have already studied, that if your AC signal is like this, then the DC signal output that you get looks like this. So it's of the same frequency. It's of the same frequency, correct? It's of the same frequency. Now, what you should understand is what is the original frequency. That original frequency is right over here. Look at this. This number, 314 is omega, because A sine omega t. So this is your angular frequency. So this is your omega. Omega is 314, but omega is also 2 pi f. So this will be 314, which I can also write 3.14 into 10 to the power 2. Pi and 3.14 gets cancelled. Frequency will be 100 by 2, which is 50 hertz. We know in half wave rectifier, input signal and output signal both have the same frequency. In full wave, what is it, guys? In full wave, what is it, guys? Come on. Yes, you can have numericals of semiconductor in the exam, Harshvardhan. Shreyas, understand, when you write these pointers, you just have to write it the way you think. Okay, this, then this, then this. There is no point me writing the answers and showing it to you. It will be a waste of time. You just need to know the pointers. Yes, it is twice. Okay, perfect. So this is the answer because it is a half wave rectifier. It's the same frequency. Last question, what is the peak voltage? Now, the voltage across the load can be given by Ohm's law. So again use Ohm's law. So what will you get? VL is equal to I into resistance. Current is 0.1, resistance is 1000. So this will be obviously 100 ohms. So that is your VL value. Oh, sorry, why am I putting ohms? It should be volts, my bad. 100 volts. That's it. Okay, got it? Understood? So you can have questions based on semiconductors also, which are numerical based, and you can have questions on Ohm's law also. Do not think that Ohm's law cannot come. Oh, I do not know, sir, that was in first term. You can never say that. If they give you, you have to solve it. You cannot say it is out of syllabus. Okay, so yeah. Yes, microwave and all of that, is it because it has high wavelength? Yes, because of that wavelength. Okay, just know you can go back little bit, replay the part. Okay, whichever part you did not understand, please replay that part. Okay, guys. Okay, 1 second. I can sense that you guys are very nervous. You guys are very scared. So guys, first of all, calm down. You know everything. It's just that even looking at simple questions, you guys are getting scared. First of all, cool it. Okay, you know everything. analyze each part of the question separately. Analyze what is asked, think about what the concept is. Don't get tensed about what was the previous or what is the next question or what's going to happen tomorrow. Pay attention, be cool, you will know everything. Yes, I can sense that. Looking at your chats only, I know you guys are nervous. Please cool down. Okay, don't worry. Answer given is 10 volt. Oh my god, sorry guys, this is wrong. This is 100 volt. This is 100 volt. Okay, that is printing mistake, ignore that. Okay, and yeah, so what is the next question? Okay, next question. If the nuclear radius of 27 Al is 3.6, then find the approximate nuclear radius of 64 Cu. Let's try to do this. Okay, Sriji is very cool. First of all, we know that inside a nucleus, the radius is proportional to the atomic mass numbers 1/3 power. So the radius is proportional to a raised to 1 by 3, and the radius of copper Cu upon radius of Al will be then a atomic mass number of Cu whole raised to 1 by 3 upon atomic mass number of Al whole raised to 1 by 3. Now I think I know all the values. Let's start substituting it. Copper I do not know, that's the only thing I don't know. Al is 3.6 is equal to, copper is 64, this is 64 raised to 1 by 3 upon Al is nothing but 27, so this is 27 raised to 1 by 3, so 64 raised to 1 by 3 is 4, 27 raised to 1 by 3 is 3, so our Cu will be nothing but 4 by 3 into 3.6, so this will go 1.2 times, 1.2 into 4, 48, so 4.8, so that should be the answer. Yep, that's the correct one. Yep. Yeah, even I thought something has gone wrong, so I was just seeing. Yeah, so this is just based on the formula R is proportional to a raised to 1 by 3. That's all. Cool. Let's move ahead to the next question coming up on your screen. A parallel beam of light of 500 nanometers falls on a narrow slit, and the resulting diffraction pattern is 1 meter away on a screen. It is observed that the minima is at 2.5 millimeters from the center. Find the width. The derivation of the formula, which one? The previous one? The derivation is not important. I mean, the derivation is not there. What is there in the derivation? There is nothing like to derive. R is, a raised to 1 by 3 is proportional. No, there is nothing like that. So first of all, you should realize that this is a question on single slit diffraction. The slit width, let's say, is A, and this is your screen. This is your central maxima, and somewhere here you get your first minima. Let's say I call this distance as y, this is d, and this is theta. This is an interference pattern which will be formed because of one slit on the screen. Maxima, minima, maxima, minima. There is a formula which I have given you for minima. What was that? So for minima, single slit, for minima, for single slit, what will it be? Theta is lambda by A. Remember this? Theta is lambda by A is the slit width. But this is for the first minima. If it is nth minima, you multiply it by n. So this is basically for the first minima. Understand that. For second minima, it will be 2 lambda by and so on and so forth. Now the next concept is, since it is given to me, where is the first minima formed? 2.5 millimeters from the central maxima, and I need to figure out A. So most likely I need to use some kind of trigonometry over here, and we can see that tan theta is basically opposite by adjacent, which is y by d, but tan theta is roughly theta for small angles. So I can just put it as y by d over here, and theta is nothing but lambda by A. So this is y by d. Now the next thing is you have to find out A, so rearrange. So A will be A, put it on the top, put D on the top, so D lambda by Y. Now start substituting all the values, you shall get it. D, the distance from the screen and the slit is 1 meter. Wavelength, where is the wavelength? 500 nanometer. 500 nano is 10 to the power minus 9. Y y is given to be 2.5 millimeter. So 2.5 into 10 to the power minus 3. So this will be 5 into 10 to the power minus 7. I can keep 2.5 as it is, into 10 to the power minus 3. 5 and 2.5 goes 2 times. So this will become 10 to the power minus 4 meters. You can also write it as 0.2 millimeters. That's the same thing. Yep. PPT will be put in the Telegram channel. You have to join the Telegram channel. Yes, Anthony, I do remember you still. Yes, Revenant got it. Understood. Okay. So remember, this small a is the width of the slit. It is not the distance between the slits. That's all. Okay. Moving on to the next question. In total internal reflection, when the angle of incidence is slightly less to the critical angle for the pair of the given medium, what will be the angle of refraction? Find the critical angle whose refractive index is 1.41. Let's do it part by part, and because there are two questions, you should always answer both of them properly without making any or without skipping any lines over there. So total internal reflection when the angle of incidence is less than the critical angle. So imagine this is our dense medium, this is our rare medium, this is our normal. Then what happens is that if your angle of incidence is slightly less than the critical angle, very close but slightly, then the refracted ray just grazes through the surface. This angle is close to 90 degrees. It's very close to 90 degrees. So that's the first answer. So there will be no TIR because this is less than, the angle of incidence is slightly less. After critical angle, TIR will occur. Here, TIR will not occur. TIR will not occur. Everybody got it? Yep. The next thing that you are going to do is for this question, find the critical angle when mu is given. You should know the direct formula. Sine of the critical angle is 1 by mu. So mu value is given to be 1.41. It doesn't look like a good number until you realize it's actually close to the root of 2. So you can approximately say this is 1 by root 2, and whose sine is 1 by root 2? Obviously 45 degrees. Hence 45 degrees is the next answer. Critical angle is 45 degrees. Perfecto. Amazingo. Excelente. Let's move on to the next question. 90 and 45. Yeah. Cool. Let's move on. Next question. Be ready, guys. Coming up on your screen. A beam of light converges at a point P, and what is asked? Now, if you place a convex lens in the path of the rays, then where do you think it converges? Okay, let's draw the rays first. We have a beam of light which converges at a point P. So we have a beam of light which converges at point P. That's what it is. It's a converging beam. Now what you have done is you have taken a convex lens and placed in its path. You've taken a convex lens and placed in its path. So because of the convex lens, what will happen is the rays will refract and they will merge much earlier. So they will meet over here. So the question is, at what point does the beam of light converge which has a focal length of 20 centimeters from the lens? Now in this question, you might be wondering how to do this question. Is it geometry? Nah. It is just based on the lens formula, nothing else. But you will be like, sir, where is the object? The object is right in front of you. This is actually your object, point P, where the rays are incident. In fact, because the rays meet at that point P, it is basically your virtual object. Yes, it is a virtual object. Rays are going this side, so this side is positive, this side is negative. Remember, real object, the rays come out. This is real object. Virtual object, the rays meet at a point. So this is a virtual object. Keep this in mind. Now, this is our final image because the rays finally meet over here. This is our final image, and this is a convex lens. So focal length is positive or negative? Is focal length positive or negative? Come on, guys. Focal length positive or negative? Vrishti has already given the answer. Very good. Let's have a look at it. Yes, the focal length is positive. So let's do this. 1 by V minus 1 by U is equal to 1 by F. V I do not know. U, object distance, is positive and it is at a distance of 12. So this is plus 12. this to this distance. Object is where the rays are meeting, and that is 12 centimeters away. And focal length, what is the focal length? It is 20. Again, it is positive. So 1 by V is 1 by 20 plus 1 by 12. Calculate the value of V. It should come out to be 15 by 2, or basically 7.5 centimeters. Just check this out. Yes, positive, Alexander. Very good, Shalma. Lyrics World, HK, Harshavardhan, Anirudh, Inikshama, G. Very good. Excellent. The answer is not 30, it is 7.5, I guess. Many of you already put it up. How P is the object? See, wherever the rays meet or originate, that's where, see, or think of it that way. Before refraction, what were they doing? That's where the object is. If they originate, that's where the object is. Or if they are meeting, that's where the virtual object is. That's how it works. Usually you do not solve questions on virtual object. So that's why many students get confused in this question. If it was a point here, then you know, oh, object is here, the rays are bending and meeting here. So whatever happens before, that gives you the object. Whatever happens afterwards gives you the image. Keep that in mind. Okay, so 7.5, the rays will converge after placing the lens. Yes, so at what point? It converges at, so you should mention 7.5 centimeters from the lens. From the lens. Keep this in mind. Okay. Let's move on. Hello Sigma, nice to see you back from yesterday. Oh, we have reached section B. Section B, 3 marker questions, bigger or trickier questions. Get ready for section B. A plane electromagnetic wave travels in space in x direction. The value of B is this much. What is the value of E vector in that location? So it's a question on electromagnetic waves, and we know electric field and magnetic field are related to each other, given by this relationship. E by B is equal to C, therefore E is equal to B times of C. Now what is the value of the magnetic field? It is given 1.2 into 10 to the power minus 8. What is the value of C, which is speed of light, which is 3 into 10 to the power 8. So 10 to the power 8 minus 8 cancels. 1.2 into 3, that's 3.6. That's your electric field. Unit is volt per meter. Now many students will just leave it over here, but do not forget, this is E vector. You need to give the direction. So E vector will also have the unit vector of it, and we know one relationship: electric field cross magnetic field gives you direction of the velocity of light. Velocity of light is along x direction, that means it is I cap. Magnetic field is along k cap. Electric field is the one which I don't know. So think, what vector cross k hat gives you I cap? What vector cross k hat gives you I cap? I, j, k. J cross k gives you I cap. So basically the answer is nothing but j cap, right over here. Simple, done, done. Can we move ahead? Very good, Ishwar Priya, Indrani, VSK Chaitanya, Vrishti, excellente, Sashmita, Atul, Inyak Lakshmi, very good, very good. Wave is in z-axis. Yes, the wave is moving along x-axis. Is the electric field which is in j-axis, or y-axis, and magnetic field is along z-axis. Moving on, yep, to the next question. The threshold frequency for a certain photosensitive metal is F0. Okay, threshold. Now this is a big question. Let's try to analyze it. Threshold frequency is F0. That means the work function is HF0. That's what I understood. Next part. When you illuminate it with light of this much frequency, maximum velocity is V0. Do I know some equation? I think so. Energy of the photon is nothing but work function plus kinetic energy. So energy of the photon will be h into 2f0. Work function is hf0. Kinetic energy will be half m. Speed is given v0 square. Take this over here. It will just become f0, hf0 is equal to half m v0 square. This is just the first part of the question. First part of the question. I hope this is clear. These questions, see guys, I'm not telling that this is the exact question which will come. Obviously, nobody can predict that. I'm telling you, these are the sure shot concepts, sure shot patterns, sure shot kind of level which will come in tomorrow's exam. These are exactly the kind of pattern that you can expect. Prince, you should know what cross what gives you what. I cross j gives you k, j cross k gives you I. You cannot use minus j. Minus j cross k will not give you I, it will give you minus I. Okay, I hope this is clear. Okay, chalo. So let's move on to the next part. And what is it? This part. What will be the maximum velocity of the photoelectrons when the same metal is illuminated by this frequency? Now, see, this question has basically two frequencies of light. First time light was of this much frequency. Second time the light is of 5f0 frequency. So I think I should be using our photoelectric equation twice. Understood? Different frequencies of light are used. So that's the reason why I'm using 2 times photoelectric equation. So I'm again going to write it down, but for a different frequency. Energy of the photon will be h times f0, but f0 is become 5 times. Work function will be the same because the metal is the same. So it will be hf0 plus final kinetic energy will be half mv1 square. Now hf0 you take it over there, so it will become 4hf0 is equal to half mv1 square. But wait a minute, hf0 is half mv0 square. No, we don't even have to divide. I mean, we can just put it. It's the same thing. Even if you divide also, you'll get the same thing. So it will be nothing but 4 times of half mv0 square is equal to half mv1 square. Half m goes 4v0 square is equal to v1 square. Taking roots, 2v0 is equal to v1. Done. Yep. So it's not 4 times, it's just 2 times. Be careful. Will they ask you to find Q value? I doubt, because according to the syllabus, they should not ask you numerical questions. But on the safer side, you can practice. But numerical questions on that will not be there. Chan, yes, it will end within 2 hours. Okay, perfect. So 2v0 was the answer. Explain with a proper diagram how AC signal is converted into DC signal. This is the question. And the question says that the output frequency as the double than the input frequency using a diode. Give the input and output waveforms. The most important word is the frequency is double, and that can only happen in case of a full wave rectifier. Recollect, full wave rectifier has 2 diodes, one diode here, one diode here. The circuit goes something like this, and there is output which is measured over here, and there is your center tap transformer. Remember full wave rectifier. And for a full wave rectifier, if this is the input, output is also very similar. If this is input, output is also very similar, right? And you have to explain it. So when you explain, you have to mention. Okay, I'll just give you the printed form and then we'll talk about it. So this is your diagram. This is your actual diagram. This is your input waveform. This is your out. Oops, sorry guys. Did I make a mistake? I'm so sorry. Output waveform will not be like that. I'm so sorry. Output waveform is going to be like this, like this, like this. It is converting it into DC. It is converting it into DC. So all the negative cycles will go away. It will come over here. These are the positive cycles which will come over here. So all the current is going to flow in the same direction. So the frequency has become double. Now while explaining it, how you're going to explain? You're going to say that in the positive cycle, D1 diode is forward bias, D2 diode is reverse bias. So the current will only flow through D1 and flow from this point to this point. In the negative cycle, D2 diode is forward bias, D1 diode is reverse bias. So the current will flow like this, and you will see that all the time the current only flows in one direction. Hence, it converts a bidirectional current into an unidirectional current. So bidirectional current into an unidirectional current. Yep. Okay. Yeah. So you will have to explain it in words. You have to write it. D1 is conducting, D2 is conducting, which is forward, which is reverse, everything. Remember, you cannot use half wave rectifier, Afnaz. It's clearly mentioned double the frequency. The only place where the frequency doubles is full wave. Half wave, the frequency remains the same. Got it? Yes. All right. Yeah. So this will be like a proper 3-marker question. 1 mark for diagram, 1 mark for this diagram, 1 mark for the explanation. That's all. Then draw the current versus voltage graph for a solar cell. Show its circuit diagram. Write the advantages, disadvantages, or actually it should be more like applications. Applications, not advantages. Applications. And what is the semiconductor material which is usually used for solar cells? So first of all, the voltage current diagram comes in the 4th quadrant, is something which is very special for a solar cell. There is no bias in it. In fact, it supplies current. Because it supplies current, that's why the current comes in the 4th quadrant. All right. And you will see that this point is where the current is not flowing in the circuit, but voltage is there. That means from the solar cell, you are not taking away any current. You are not using that energy. So this will have max voltage. Max voltage. This is also called as the open circuit. This point over here, you will notice that the voltage is 0, current is basically maximum, and this will happen when you connect a wire across the solar cell. Maximum current will flow across the wire and there will be no potential difference or minimum potential difference. So this is called as a short circuit. Most of the times your actual operation will be somewhere here where current will neither be maximum nor minimum. Alright. And having said that, you should also show the circuit diagram. P-N junction. Obviously, from N electrons will come out, from P holes will come out, and the circuit will be complete. Since electrons are going like this, current will go exactly opposite way. And you can show a load or some kind of a device connected to the solar cell. That's your diagram. Which material is used? Which material is used? Yeah. GaAs and silicon. Yep, you will see. First this diagram done, this diagram done. Okay. Oh, which material you will use? You will use GaAs, yes, or Si. Now, why do you use this? Because their energy band gaps match with the exact energy of the solar rays. The rays of the sun are nothing but electromagnetic radiation or photons. The photons energy matches with these two semiconductors band gap energy, and hence it can give you very nice current. Anything else will not match with it and you will not get good amount of current out of it. So there are only certain elements which are used for solar cells. You should remember the names. Talking about the advantages and the disadvantages or applications. Applications is in your calculators or your space stations or solar street lamps or anything which can be driven through solar chargeable batteries, anything. Disadvantages is it is very expensive, also very less efficiency, and it is very unreliable because if the rain comes, cloud comes, then the solar energy will go away. So those are the pointers that you will mention for 3 marks. Only then you will get all the 3 marks. Let's move on to the next one. NCERT does not have different diagram. I think NCERT has the same diagram, bacha. It should be the same diagram. Okay, cool. Alright, as long as the concepts are same, if minor, small here and there, it's not like PN means it should come here only. If it is on the top also, it's fine. As long as you draw the same concept, don't worry. Alright. Okay. MJ12, apart from my sessions, please give the mock test and NCERT underline, whatever PDF I have given. Also, NCERT back exercises. Okay, I hope this is clear. Oh, that diagram. That is the construction, that metallic strips are connected to one layer, then there is a silicon wafer and then the other terminal is taken. That is the construction of a solar cell, that is different. In YDSE, when you have identical slits, the intensity on the screen varies from 0 to 4 times the intensity due to one slit. Explain it and also give the mathematical expression. Now, you should remember the formula. If the slits are identical, each slit gives an intensity I naught, then the resultant intensity is given by 4 I naught cos square phi by 2. Do you remember this formula? Cos square phi by 2 into 4 I naught. That's the resultant intensity due to the interference. Due to interference. This is the formula that you're going to use. Now, maximum and minimum intensity changes from 0 and 4 I naught. So let's see why it happens. When you get maximum intensity, that means constructive interference is happening, and in constructive interference the phase difference is 0, and if phase difference is 0, cos of 0 is basically 1, hence you get the intensity as 4 times of I naught. This is the intensity that you get when the interference is constructive. But when you are talking about dark or minima, then it is a destructive interference. The phase difference is 180 or opposite in phase. Cos of 180 is obviously minus 1. Minus 1 square is 1. Cos 180 is minus 1, but you will not find 180 is cos, you will find cos of 180 by 2. 180 by 2 because it is phi by 2. So basically it will be 180 by 2, which is 90. Cos 90 is nothing but 0, and hence the value of the intensity will also come out to be 0. So 180 by 2, that's 90. 90's cos is 0. So you can see, hence the intensity varies anywhere between 0 and 4 I naught. That explains that statement through a relevant mathematical expression. That's all. Okay, I hope this is clear. Anirudh, isn't constructive interference phase plus 1? That is a general expression. Phase difference can be 0, 2n pi, 4n pi, like that. For destructive, it will be pi, 3 pi, odd pi basically. Chan, I have done the derivation of Lensmaker formula yesterday. You can check it out from previous class. Can we use I1 plus I2 plus 2 root? Ideally you can, but in NCERT this formula is given. I would stick with NCERT formula. That's all. Dacon, yes, why not? Well, Muhammad, I would prefer writing that negative sign, and I will say that the image is finally inverted. So mention in the answer sheet that negative sign I have put only because of the inversion. Otherwise, magnitude wise it is just, modulus wise it is without the minus sign. So put it on the safer side. That's all. Who said MJ12? You are listening to the wrong people. Good evening, Harsha. If any question they have given frequency, then it is W or F. See the units. If it is hertz, it is F. If it is radian per second, it is W or omega basically. Usually when they say frequency, it means hertz. If they mean angular frequency, it is omega. Okay. Alexander, all the important definitions in wave optics I have given in yesterday's as well as also in the NCERT PDF. I have shared the NCERT PDF with all the important definitions and whatever pointers you should know, be it Huygens principle, definition of wavefront, what is the meaning of ray, Huygens construction, all those things I have mentioned. Definitely Thalapati, you will be. Okay. Yes, it works, X Arun Karthik, it does work. I didn't highlight semiconductor, is it? Oh, okay. I'll just check it, and if it is not, I will just share it. Don't worry. So do we need to, or anyways, now is not the right time. You only underline the last section. That will be better. Okay. So let's, silver balls. Man, I'm not your bro. I'm your sir. Sorry, I won't conduct. If the slits in YDSE, acha, this is done. Okay. Let's move on to the next one. The focal length of a convex lens made of glass is this much. What will be the new focal length when it is in a medium of this much refractive index? And is it positive, negative? What does it mean? Let's try to figure this out. Okay. What if pi by 2 is the phase difference? Then obviously Akash, cos of pi by 2 by 2, which is pi by 4. So accordingly substitute. It will be between 0 and 4 I naught. Now, in this question, I think you should use Lensmaker formula. So 1 by f is equal to mu minus 1 by r1 minus 1 by r2. So this is the focal length first time when the refractive index of glass is given. Second time what happens, that the focal length changes because the refractive index is going to be different. Reason being, since you have dipped the lens in some solution, the relative refractive index will be quite different. When we use the Lensmaker formula, this mu is always with respect to air, but if you dip it in some medium, it will be with respect to the medium. So this will be the relative refractive index minus 1. R and R will be the same. So I feel you should divide this now. You should divide this on both sides. So this will be 1 by F1 by 1 by F2 will be equal to, these two will cancel, mu g minus 1 upon mu relative minus 1. This will become F2 by F1 is mu g minus 1 upon mu relative minus 1. Now the focal length second time is what we need to figure out. That's what we need to find, what is the new focal length. So F2 is unknown, F1 is given, the focal length is 20 centimeters, glass refractive index is 1.5, and over here relative refractive index, is it going to be 1.5 by 1.25 or is it going to be 1.25 by 1.5? Nasho Khato, this is an English channel, so we'll be speaking English. For Hindi, I'm there on other channel which is called as NEET Mediji. So will it be, yep, think about it. It will be 1.5 by 1.25, higher number by lower number, because obviously relative refractive index of glass with respect to the medium. So glass's refractive index with respect to that medium. That's what it's going to be. 1.5 minus 1 is 0.5. 1.5 by 1.25, you can make it as 150. 150 by 125 minus 1. This goes 5 times, this goes 6 times. So this is 5 times. 6 by 5 minus 1 is nothing but 1 by 5. So this will become 0.5 into 5. Okay, so bring that 20 on the top. That 20 which was there, bring it on the top. So F2 will be 20 times 0.5 into 5. So 20 is half is 10, 10 5s are 50. So it will be nothing but 50 centimeters. That's the answer. Yeah. Done, done. All right, perfecto. Amazing. Go see this. 50 centimeters. Oh, and oh my God, why the answer given is wrong? This is 50 centimeters. My God, I don't know, the printing mistake. And now talking about what do you infer from it? Is it positive or negative? Obviously the answer is positive. The positive means it behaves like a convex lens. That means it is still converging lens only. The focal length changed because it depends on the refractive index relatively. But since the answer came out positive, the good thing is it still remains convex. What if this medium which is there over here, 1.25, this is your medium, this is your medium. What if the medium was more dense than glass? Let's say it was 1.7, then what will happen? What will happen? No, it will not be 0.5 by 0.25, that is wrong, Thalapati. Lot of questions, half the questions are over. Then this will be negative, it will become a negative answer, value might be different. Hence, it will be a diverging lens, it will behave like a concave lens. That's what will happen. That's what will happen. Correct. Alright, moving on to the next one. The total energy of an electron in the first excited state of hydrogen atom is about this much. What is the kinetic energy of the electron in this state? What is the potential energy? What is the answer? Will it change if zero reference is changed? Okay, let's try to figure this out. The energy of an electron in its excited state in some random atom is minus 3.4. So energy in its excited state is minus 3.4 electron volt. This is your obviously total energy. The question says what is the kinetic energy? I told you during atomic structure that the value of the kinetic energy is always negative of the total energy. Negative of the total energy. So basically this is negative of 3.4. So it will be plus 3.4 electron volt. That is your kinetic energy. Next thing is what is the potential energy? I had also told you that the potential energy is twice of the total energy. So basically in this case it is twice of minus 3.4. So it will be minus 6.8 electron volt. That's it. 2 questions done. Each question will fetch you 1 mark. last thing over here is, will the answer change if zero reference is changed? The zero reference is only valid for potential energies, and usually zero reference is at infinity. We assume that at infinity the potential energy is zero. At potential energy is zero. Ranveer, sorry bacha, I will not solve fast. I will be solving at this speed only. If you want to watch it, you need to watch it at this speed. At infinity only the potential energy is zero. That's how you assume the potential energy. And kinetic energy is always half mv square. It's the absolute value. So it does not depend on the reference. So if you change the reference, what happens is this will definitely change. If you change the reference, this will change. This will not change. This will not change. And since the total energy is the sum of kinetic and potential energy, hence you will see the total energy will also change. But I know this is not asked, but I'm still answering that question in case that was asked. Which of the answers will change? Kinetic energy will not change. Potential energy will change because it depends relative to the zero reference. Total is dependent on both. So one of them changes. Obviously the total sum will change. Okay, Ranveer, I have to think about other students. I'm thinking about the most average student in the class, and I will be going at the average speed only. Okay, I hope this is clear. Let's move on to the next question coming up on your screen. Potential energy changes, nothing else changes. Okay, so we have the next question, guys, coming up on your screen. Check it out. Yeah, check it out. So what is the question? I miss my water. Afna's case studies can come from any chapter, but I am guessing it will come from more theoretical chapters like semiconductors, or even EM waves it can come, or these are most probable chances, most likely chances that it will come from one of this. Okay. Now let's move on to this question. What is there? Name 1 point difference between nuclear fission and fusion. Now in fission it breaks, and it breaks, that means it should be of a very high atomic mass number, very heavy nucleus which is unstable, which has lower binding energy per nucleon. It splits to form more stable nucleus. That's when fission occurs. Okay, so that's 1 point. I can also give example of uranium breaking down. And then for fusion, lower atomic mass numbers which have very less binding energy, they fuse, they combine together to form a bigger, bulkier nucleus which is more stable and has more binding energy per nucleon. That is called as fusion. You can give example of hydrogen combining into helium. Now the next thing that you should know is that over here ferrous is getting decomposed. It is splitting into 2 nuclei of Al. If you notice, this is 56, this is 28, it's exactly half. So Fe splitting into, that's basically fission, that's fission, 2Al. Now this is your reactant, this is your reactant, this is your product. Fair enough. And we have to figure out, is it energetically possible? Is fission possible? Whenever fission happens, remember one thing, it should be such that when it becomes a product, it should be much more stable than the previous one. The product should be stable than the reactant. Be it fission, be it fusion. Always energy should come out, mass should be lost, so that it becomes stable. Now, if you notice over here, the product's mass and reactant's mass. The reactant's mass is clearly given right over here, 55.93494. Product's mass product's mass will be twice because there are 2 aluminiums. So 2 times of 27.98191. So what will this come out to be? 2 times 27. 2 times 27.98191. No, don't need to multiply by 931 also. Just check it out. I know Anirudh, Fe is more stable, but you have to justify it. So you cannot say I know it already. Then the examiner will not give you marks. Obviously, the examiner will not give you marks. 56 approx. But 56, yeah, where in 56? So just figure that out. 55.96382. Yes, 55.96382. Some student has written. Just check this out. Now, if you compare both of them, if you compare both these values, you will clearly see the mass of the product which is formed. The mass of the product which is formed is more. This is less. Product has more mass. Mass is created. That means energy is destroyed. Energy is taken in. It is not released. Energy is absorbed. That means Q value will be negative. Hence, it is not possible. It is not feasible to conduct this fission. It's not good. Study hard. My specs. Oh, it's here only. I forgot. Oh, I forgot to wear it. Oh, under tension. Yeah, I can wear it. It's not spectacles. It's just a filter. That's all. Yeah. Is that clear? Q value should be positive for it to be feasible. If it is negative, then it is not feasible. Yeah, you can multiply it by 931 to find out the value, but I don't think they will ask you questions to find Q value. If they ask you to find out the Q value, take the difference multiplied by 931. Otherwise, it is not needed. No, otherwise it is not needed. Is that okay, guys? All right. I hope, Afnaz, that is clear. There is no need to convert it into Q value. Justify your answer by Q value. How are we justifying? Since we saw product's mass is more, hence energy will be absorbed, hence Q value is negative. So I've justified it using Q value. The Q value is negative. We don't need the value. I know it is negative. How much negative? I don't care. It is negative. Once it is negative, gone. It is not feasible. I hope this is clear. Okay, let's move on to the next question. Okay, in Young's double slit experiment using monochromatic light of wavelength lambda, the intensity at a point on the screen where the path difference is lambda is k units. What's the intensity of a light at a point where the path difference is lambda by 3? Let's try to figure this out. Okay, now for this question, what you're going to do is basically think, is there a way intensity can be related to path difference? If you don't remember a formula, then indirectly relate it. Intensity is dependent on phase difference. Phase difference is dependent on path difference. So if I know that the path difference is lambda, the phase difference, which is 2 pi by lambda into delta x, so which will be 2 pi by lambda into lambda cancels, so it will be 2 pi. Okay, it will be just 2 pi. So once I get this as 2 pi, I can find the resultant intensity, which is 4 I naught cos of phi. Phi is nothing but 2 pi by 2. So this is square. So 4 I naught cos of pi, cos 180 is minus 1, square it, it's 1. So it is just going to be 4 I naught. That's it. That's the resultant intensity. And this is what is given. What is given? This is given to be k units. So this is given to be k units. Done. Now, for the second part, when the path difference is this much, how much is the new intensity? So now for the second case, delta x is lambda by 3. So phase difference is 2 pi by lambda into lambda by 3. Lambda cancels, so it will be 2 pi by 3. So now the resultant intensity will be 4 times of I naught cos square phi, which is 2 pi by 3 by 2. Now 2 cancels, so it will be just nothing but 4 I naught into cos square pi by 3, which is nothing but 60 degrees. 4 I naught is just k, so just put k over here. Cos 60 is half square is 1/4, so it will be nothing but 1/4. So the total intensity is k by 4. Done. Okay, I hope this is clear. In binding energy of products is greater, then the reactant energy will be released or absorbed on Y. If binding energy of the products is greater, then the reactant energy will be basically, see, if the binding energy of the product, so on the product side, if it is more, that means it releases more energy, so energy will be finally released. It is becoming more stable. See, remember one thing, binding energy directly related to the stability. So if binding energy is more, it is more stable. If it is more stable, it will release energy. That's all. Okay, I hope this is clear. Let's move on to the next one. Okay, what do we have here? The angle of prism is this much, refractive index is given, determine the values and for incidence and deviation for minimum deviation. So the keyword over here is minimum deviation. Let's start with it first. So for minimum deviation, delta minimum, I1 is equal to I2 and R1 is equal to R2. I think I can find R1 and R2 because I know that R1 plus R2 is equal to angle of prism. So twice R1, because they are equal, is angle of prism, which is 60 degrees. So R1 is 30 degrees. R1 is 30 degrees. Q is negative, Divya. That means it is absorbing. It is not releasing. Be careful. Q is negative, it is absorbing. Okay. Now, once I get R1, I can use Snell's law. So let's use Snell's law. Let's use Snell's law and we'll see what do we get. So using Snell's law, what do we get? Sine of I1, because this is angle of incidence, this is angle of refraction, upon sine of R1 will be mu. So sine of I1, R1 is just given over here. I just found it out, 30 degrees. So sine of 30 is mu. Mu is root 3. So what do we get? Sine of I1 is root 3 into sine 30 is half. So put half here. So root 3 by 2. Whose sine is root 3 by 2? Obviously, it is nothing but 60 degrees. So I1 is 60 degrees. Done. Once this is sorted, the last thing is finding the deviation angle. So there is a direct formula for that. So delta is I1 plus I2 minus A. So that means it will be 60 plus 60 because both angles I1 and I2 will be equal, minus A angle of prism is also 60. 60 minus 60 is 0, so it will be just 60 degrees. So that's your minimum deviation. No, you cannot use delta is mu minus 1 into A, Shreyas Jerome, because why can't you use that? Anybody knows? You cannot use delta is equal to mu minus 1 into A. Why we can't use? Anirudh. Anirudh is also asking the same doubt. Reason I had told you yesterday. It is only for thin prism. Thin prism. This is 60 degree thick prism. Maximum how many derivations? At least you will get 3 derivations. At least 2 to 3 derivations minimum. No, many derivations are there, guys. I mean, come on. Optics and waves have maximum. Atomic structure has few of them. So obviously 2 to 3 derivations you will get. Optical density is basically the media density in terms of bending of light. So if the light bends towards the normal, it is said to be more dense, but it does not mean kg per meter cube. It is not your mass density. It just tells whether the light bends or is away, or whether the speed becomes less or more. If the speed becomes less, it is more dense. If the speed of light becomes more, it is optically rare. 3 diodes are used and they have these many band gaps. Which of them will not be able to detect light of wavelength this much? Okay. Yeah. Manoj, I won't be doing paper discussion. I'll be concentrating on KVPY. Okay? I think concentrating on KVPY will be more important. I hope that is understood. Now, in this question, try to understand what is the meaning of it. 3 diodes are used. Which of them will not be able to detect light? So, if you want to detect light, what happens is that you have your 2 bands. One is your, valence band, and this is your conduction band. The electron should be able to jump through the band gap. So, the band gaps are given. So, you should be able to jump through the band gap by absorbing a photon. By absorbing the photon. That means the photon should have enough energy to push it from valence to the conduction band. Now just see what is the energy of the photon. So the energy of the photon is hc by lambda. hc by lambda, I can also write it as 1240 by 600. Remember 600 is in nanometers. So yeah, so I can use that. This is in electron volt, of course. This goes, oops, sorry, I cancelled one more extra zero, my bad. This is 0 as it is. Now this value, if you notice, this 0 has gone. This value 60 and 124 will be 2 point something, but not 2.5 or anything, 2.1 or something like that, 2 point something, very close to 2.1, very close to that, very close to that. Now once you know that it is very close to 2.1, realize that 2.1 is actually more than only 2 electron volt, but it is less than 2.5 and also less than 3. 2.5 is the band gap of diode D1, so this will not conduct. 3 electron volt is the band gap of diode D3, so this will also not conduct. 2 electron volt is the band gap of diode D2, so only D2 will conduct. That's all. I hope this is clear. Understood? Clear? Yes. 2.06, I can approximately take it as 2.1. That's fine. Yes, today we will be discussing case study also. So in Lakshmi, what has happened is, this is a basically question on photodiode. Photodiode, how it works? Basically, when light falls, it triggers the electrons, it makes it more conductive. So when will the electrons be able to jump into the conduction zone? If the photons have enough energy. So I'm first calculating the energy of the photon. The value of H into C, you should know this standard value. How many of you know this? How many of you know this? This is basically your 1240 by lambda. If it is in nanometers, this is in electron volts. So I just substituted 1240 by 600. That's all. That's all I have done. Okay. And after that, I saw 2.1 is only more than 2. So it only crosses for that, which diode? T2. Other diodes it does not cross. Okay. Yes, I did it on Vedantu JE channel in Hindi. Yes. Can you explain the band gap greater or less? No, Siswa, it does not come 0.26. You have done some calculation mistake. D2 will detect, because what is the gap for D2? For D2 the gap is 2, but the photon's energy is 2.1. Photon has more energy, so it can easily propel that electron from that 2 electron volt gap. That photon has more energy. Yes, I hope this is clear. Everybody understood? Let's move on. Okay, let's come to case studies. Study hard. KVP preparation will only happen, I had mentioned on community, you can check it out. It's already there. Tomorrow board exam is there. Obviously I'll be focusing on board exam, not the KVPY. KVPY, I had already mentioned that you already have the crash course. Make use of the crash course, join the crash course, watch the lectures, give the mock tests, solve the assignments. Already have enough material. Tomorrow I'll be doing KVPY preparation, not today. Tomorrow, after the exam. If it is in Armstrong Vineet Kumar, then it is going to be 12400, and lambda will be in Armstrong. Then there is one extra 0 over there. Keep that in mind. Let's move on. Okay, moving on to the case study. So the paragraph is given, but most of it will be irrelevant, or I mean, even if you don't read it, most of the times it will work. You will see that. Okay. Mridula, I am doing a lot of numericals, and I am also doing a lot of theory questions, if you did not realize it. Explain the diagram of this, explain the advantages, disadvantages. I have done a lot of theory questions, number 1. Number 2, derivations will come. I already told you that today I will not do derivations. Why? Because it's already done yesterday, so a lot of derivations will come. So those two will take up a significant chunk of your definitions and give reasons or explain drawing diagrams, charts and all of that. And what will happen next is only the remaining part will be your numericals. Obviously, Jay Ajinkya, that was in Hindi. This is English medium, Jay. Okay, so this will not be given. This you need to remember. Electromagnetic spectrum. Let's start with the questions coming up. Okay, so which wavelength of the sun is used finally as electrical energy? Which wavelength of the sun is finally used as electrical, or basically this should not be there, electrical energy, in any form of energy, in any form of energy, which light is used? It is not visible, it is infrared. I had told you that infrared is basically heat. The infrared rays from the sun get trapped within the atmosphere, which causes the heating effect and greenhouse effect, and when you use this heat can be used as energy. Basically these photons, these radiation can be used to start many devices, many appliances. So it's infrared. Moving on to the next question, which of the following electromagnetic radiation resonates with water molecules? So I have a doubt, that is photodiode working principle of the photoelectric emission. Photodiode, very similar. You can see it's very similar to that. Okay, it is, which of the following electromagnetic radiation resonates with water molecules? Microwaves, right? Microwaves, correct? I told you in microwaves, the microwaves resonate with the water molecules. The water molecules vibrate, they produce heat and they increase the temperature. Perfect. Moving on. Which one of the following is not electromagnetic in nature? There's one of them which is not electromagnetic in nature. Which of it is that? Is it X-rays, is it gamma rays, or is it cathode rays, or is it infrared? It is obviously cathode rays. Cathode rays are basically electromagnetic, it's just electrons. So gamma rays are EM waves, X-rays are also EM waves, infrared is also EM waves, is the cathode rays, which are nothing but just electrons. So that is the one which will be ruled out. Perfect. And if I talk about alpha rays are also particle rays. So they are also not electromagnetic waves. Alpha rays are made of doubly ionized helium. Keep that in mind. Which of the following has minimum wavelength? X, ultra, gamma, micro. Okay, Jairam, you asked a valid question. Will case study be objective or subjective? It can be objective, it can be subjective. If, let's say for example, it is subjective, imagine the options will not be there. Yeah, these kind of questions can't come, but let's say you can have a previous question like this. Which electromagnetic radiation resonates with water molecules? Options are not there, but it is microwave. So it can come without options also. So which of the following has minimum wavelength? Yes, it is gamma rays, guys. Gamma rays has the shortest wavelength. It has the highest energy. It is used to treat cancer cells. Out of this, in fact, microwaves has the largest wavelength. First is micro, then is ultra, then is X, and then is gamma. Okay, let's move to the next one. The decreasing order of the wavelength, infra, micro, ultra, gamma, is decreasing. Highest first, lowest last. Highest first, lowest last. Figure this out. He asked about photodiode. Okay. Photodiode is different from photoelectric cell. Be careful. Okay. Guys, the answer is A. Microwave has the largest wavelength out of this. Then red is longer than ultraviolet. We know that. Okay. And then gamma is very, very short wavelength. Gamma is the shortest of the all, very energetic. It comes from nuclear reactions. Keep this in mind. Microwave is 10 to the power -3, -4, -5, in that range. Infrared is in the range of 700 plus nanometers. Ultraviolet is below 400 nanometers. And gamma rays, obviously, very less, 10 to the power -13, 14, 15, that range. Okay, next passage based on total internal reflection. Read this out. So it's based on total internal reflection, your optical fiber network. You should be able to do this. Come on. Photodiode is there, Janya. Let's try to figure this out. Mehul, I'm not from Nagpur, I'm from Pune. Okay, let's do this. I hope you have taken a screenshot, you have read through this. You can pause the video also if you want. L in the compound microscope's magnifying power is the length. It's the distance between objective lens and objective lens and eyepiece lens. So let's try to solve the questions. Which of the following is based on the phenomena of total internal reflection of light? Total internal reflection. Sparkling of diamond, optical fiber, instrument used by doctor for endoscopy, all of these. Come on, think about it. Come on, think about it. Obviously, sparkling of diamond, yes. It reflects multiple times, that's why it sparkles. Optical fiber, yes. Do I know this? No. But I know if two options are correct, all the options should be correct. So what happens in endoscopy, there is a tube which goes inside and basically internal reflection happens through which the doctor is able to examine whatever specimen is there. So it's again based on the tube, which is very similar to the optical fiber network, all of these. Next, a ray of light will undergo TIR inside optical fiber if the condition, if goes from rare to dense, less than critical, strikes at normal, is more than the critical. Okay, perfect. It is option D. It is incident at an angle more than the critical. We know that at critical angle it's just 90. More than that, it is basically total internal reflection. So this is your critical angle. Correct. It should be more than the critical angle for it to be totally internally reflected. Next, if in the core angle of incidence is close to critical angle, then the angle of refraction will be close to. Angle of refraction will be close to. No problem, Mehul. You can eat along. Think about it. If the angle of incidence is close to the critical angle, then the angle of refraction will be close to obviously 90 degrees. Option C, perfect. Excelente. Amazing go. Very good. Moving on to the next question. In an optical fiber shown, correct relation for the refractive indices, this is N1, this is N2, is which one is more, which one is less, or both are equal? B, saying Sanjit. Think about it carefully. B, C, A, or something else. Obviously, if it has to get internally reflected, naturally this should be in the dense medium, this should be in the rare medium. Dense means N1 is more, N2 is less. So N1 is more, N2 is less. That's option B, of course. Option B. This is dense, so N1 is more. This is rare, so it gets total internally reflected. So that's why N2 is less. Moving on to the next one. Exarun, I have explained mirage effect in the ray optics class just 2 days back. Just open up that lecture. It's there on the channel. Explained it, how it happens. If you still have a problem, just search for Shreyas Sir, total internal reflection or refraction. In that class, I've explained it in detail again. Just have a look at it. It will be better because each person will have a different kind of doubt. All my lectures are available, okay, on the channel. So if the value of critical angle is this much, so sine of 30 is 1 by mu. That's the formula for finding refractive index and relating critical angle. Sine 30 is half, so that is 1 by mu. So mu is basically 2. Speed of light in the medium is speed by mu, and that is speed of light in vacuum by mu. 3 into 10 to the power 8 is C. Mu is just 2. So this is 1.5 into 10 to the power 8. Done, done, done. Done, done, done. Option B, yes, it is option B. Perfect. Amazing. Amazing. Next question on semiconductor case study. Let's try to figure this out. Notice the graph, notice this passage, take a screenshot, read through it quickly. I'm going to ask you questions. This is current versus voltage characteristics for a light emitting diode for different colors. Different colors. Okay, this is LED. Let's try to do this. The energy of radiation emitted by LED is energy of radiation. Whenever energy comes out, the light comes out, what do you think is that energy equal to? Yes, just now we did. Is it A, greater than the band gap? That was photodiode. See, you guys are getting confused. Yeah, that greater than the band gap. The energy of the photon should be more than the band gap if it is absorbing that photon. But when you have a band gap, the energy which is released, will be obviously less than or equal to that gap. Whatever that gap is there, that much energy is the maximum energy you can get, and anything less than that is also okay. So it is not B or A, it is not even C, it is D. Equal or less than the band gap. So the energy which comes out released is less than the band gap between them. Yeah, it can be based on directly picking or from previous knowledge. Be careful. A lot of people think that passage questions or case study will be completely dependent on the passage. Not necessarily. Some of the data, yes. Some of the data might be related to your memory power, whatever you have studied in the term 2 syllabus. If you do not remember it, sometimes you might face a lot of difficulty. Moving on to the next question. Which of them is the correct symbol of the diode? Which of them is the correct symbol of the diode, light emitting diode? Is it A, B, C, D? Ishwar, C. Okay, I'll explain you what happens in just a minute. Hold on. Yep, these are normal diodes. These are just normal diodes. That is actually a Zener diode. There is one line over there. This is normal diode. This is light which is coming out, LED. This is photodiode. So yes, the answer is D. See, understand the difference. In a photodiode, there is band gap. This is valence band. This is conduction band. This is basically your gap. One second. This is basically your gap. So in photodiode, if light falls, light's photon falls, if that energy is more than the gap, at least more than equal to, only then it can move up. Understood? So the energy of the light should be enough to push it up into the higher band. Whereas in LED, you have these two bands. When the electron jumps to a lower energy state from conduction to valence band, that's when the photon comes, that's when the light comes. Obviously, this light energy will be less than or equal to the gap energy. Is that making sense? Understood? Clear? Done? Fair enough? Okay. LED is constructed from a p-n junction based certain materials whose gap is 3.1. Identify the color emitted. Okay, now this is completely based on this. Identify the color emitted. Chalo, figure this out. Some of you are saying C, some of you are saying B. Figure this out. Term 1 mark will be obviously added, Afnaz. What? They're not going to forget your term 1 marks. Obviously your practical marks plus term 1 marks plus these marks. Together you will get the final score. Shreyas wants to have chit chat. I will have chit chat towards the end. Don't worry. What to do tonight? Just revise the formulas. Go through my formula notes, mind maps. Revise through it, and just solve few questions or just write down few derivations once again and sleep off. That's all. Okay. Here, whose band gap is this much? Matlab that energy difference is going to give you the energy of that photon. So energy gap is 3.1 electron volt is 1240 electron volt by lambda, which is in nanometers. So that value of lambda comes out to be 1240 by 3.1, which is 12400 by 31. 31 goes 4 times. So this should be 400 nanometer. We all know that the visible spectrum, violet and red, violet is 400 nanometers, red is 700 nanometers. So it is nothing but violet color. Yeah, it is 50-50, but it's also including your what do you say, your practicals, internals course. It is not red. It is not red. It is violet. Okay, I hope this is clear. Understood? When the image is obtained at infinity, should the negative sign be ignored? In the exam, what you do, you put the negative sign and mention that it is inverted. Okay? Or else just say the magnitude. Better will be, you can say the magnitude of the magnifying power is this much. But the image is inverted, so actual magnification will be negative. You can write it like that. Okay? No crazy master, it's not. Well, next question. Which of the following statement is not correct in case of LED? Which of the following is not correct? Sir, प्रश्न येतील real and apparent depth height. Doubtful. Doubtful about it. They can, but it is going to be like very simple. H by mu or mu h. Very doubtful. It's going to be the same thing, Shreyas. C or B. It is heavily doped. Yes, it is very heavily doped, so that more the doping, more the conduction, and more light will come. It emits light only when it is forward bias. Yes, LED is forward bias. Photodiode is reverse bias. It emits light only when reverse bias. That is wrong. Energy of the light emitting diode is less than the energy of the gap. Yes. So whatever energy comes out is less than the gap energy. So because when the electron transits from upper to lower band, you will see that loss in the energy converts into light energy. Yep. So option C is wrong. All others are correct. Perfect. Excellent. So it's now time to just probably have some chit chat, and I'll give you the final words before your examination. One thing, you should also check out the links in the description box for your crash course of NEET and JEE. A lot of lectures are there. So I would feel that you should join the crash course immediately after your term examination and start preparing, because you have a good gap before biology as well as maths. So a lot of classes, lot of assignments and lot of tests which need to be completed before your JEE and NEET. And the best thing is it's just for 2,700 bucks. Recordings are available. Don't look at this date. Okay? Recordings are available for you right now. Recordings are more important than live classes. So thank you guys for first of all liking and subscribing and joining in today's session. Now what you need to do tonight and what you need to do tomorrow morning. So first of all, tonight don't read anything new, number one. Number two, you can practice few derivations once in for all, just in case you have some doubt. If you are confident, then it's okay. I mean, if you think about it, then you will feel like doing everything. So only pick the important ones, maybe the ray optics or the wave optics ones, and what is that, your atomic structure. Just see which derivations you don't know, just recollect whatever steps are there, and then what you should do is just go through the important underlined points and the mind maps. Acha, in semiconductor, what are the things? Okay, photocell, remember the diagram. Okay, LED, what is the diagram? So recollect all the diagrams before you go to sleep, but don't try to unnecessarily read and get tensed. Tomorrow in the morning, once again, you can just do the same thing, revision, but only for a small amount of time, not more than 1 hour. Not more than 1 hour, max to max 1.5 hours, because you will have to leave your house, you have to get up, you have to do your morning course and all of that. So make sure guys, you finish whatever you have to do tonight only. Don't keep anything for morning, but sleep at least for 7 hours, drink well, have breakfast properly, and do not talk to random people. Do not get fooled into thinking I'll get the paper, leaked paper somewhere. No, these are all rumors. Okay, keep this in mind. Derivation of Lensmaker, yes, you should do it. Derivation is very, very important. Okay, so is there a chance of cancelling term 1? Hey, come on man, no. Just know, where do you read all this? Hey, Prashna Pahun Sanana Asha Nirman Dhali. Okay, thank you. Welcome Ridula, and welcome Sweta. Sir, book back is important. Oh my god. Let's talk about whatever is there in board right now. We are talking about boards. Welcome Lakshmi. Welcome Sanjit. Glad you guys were here. And Ankit, Bye bye, take care, do well, Revenant, do well, Pranav, do well. And guys, make sure that whatever we have done so much over here, you please, you have to make me and everyone proud, okay? And you will do well. Please don't feel discouraged at any point of time. Do whatever you know. Think coolly, just be calm. You will get it. Derivations, very important. I'm telling you again, lot of marks. Diagrams, charts, second important. Semiconductors, ray optics, very important chapters, along with wave optics. Wave optics, I can put it on second or third priority. After that, all the other chapters. Other chapters are simple, dimple, easy peasy. Okay, do it. You will rock it. Tomorrow onwards, KVPY preparation on this channel, and after that, what are we going to do? JEE and NEET preparation. All gear up. It's exam time. Full Josh, high on energy. It's going to be very high, intense classes now onwards till you crack your JEE NEET final examinations. Bye bye, guys. Have a great time. All the very best. Your favorite captain was here live for all of you, just so that you can score well. Take care. Hasta la vista. Bye bye. Have a great time.